I'd like to tell you something about it, and I have a model here in the laboratory that I can show you. Now, the thermionic converter you see here demonstrates the principle. I turned it on a few minutes ago. It takes a moment to warm up so that you could see it in operation. What you see here is the converter itself, which is this device, like the one I'm holding in my hand. There are two discs of metal sealed together with a separating ceramic ring. The function is quite simple. In fact, the thermionic converter is probably the simplest method of creating electricity. We heat one of the metal discs on the bottom with a flame. In so doing, we boil out electrons from the metal. We collect the electrons in the top plate. Now, that flow of electrons produced directly from heat is electricity. I'll turn this device off. It'll take a few minutes for the flame to go out and for it to cool down. So here is another method of producing electric energy. In this case, a direct conversion of heat to electricity. Now, the concept of the thermionic converter has been known for some time. The trick has been to make the conversion efficient. The best converters we now have in the laboratory will accomplish this conversion with a conversion efficiency of about 15%. This is far short of a turbine generator, but still in a useful range for many special applications. So by the various means of producing electric energy, various new means, some new in concept, some new in embodiment, we are finding more versatile applications of electricity, sometimes lighter in weight, sometimes more efficient, sometimes more compact. Actually, modern civilization is just now at about the threshold of the age of energy. Energy is an increasingly important driving force in modern civilization. And the ability to produce this kind of energy in ever-increasing quantity and in ever-increasing versatility is very important to future progress of civilization.
Essentially, what the reactor does is provide electrical power and the base gravity wave to amplify, and it does that by interacting matter and antimatter, essentially. The way it does that is injecting an accelerated proton into a piece of 115 that spontaneously generates antihydrogen, essentially. That's reacted in a small area. It's a compressed gas, probably a compressed atmospheric gas, and the antimatter reacting with matter produces the energy, mainly heat energy, and that is converted into electrical energy by a thermionic generator that appeared to be 100% efficient, which is, a difficult concept to believe anyway.
From the energy of the atom, invisible to man's eyes, to the vastness of the universe, staggering to his intellect, the frontier of science stretches forth, and the men of science strive to press it back, patiently, tentatively, step by step. Two of the major challenges on this frontier of science are the exploration of outer space and the development of sources of energy.